here to speak to you about nanotechnology and biomedical engineering. I know these fields sound kind of intimidating, but I hope that I will be able to not only clarify these fields for you, but also convey some of the curiosity and wonder that really drive my passion for this work. Medicine is an ever-changing, ever-improving field that must create solutions for the problems created by disease. As time goes by, doctors and researchers are constantly on the lookout for bigger and better solutions that can provide safer and more effective treatment for patients. One of the most promising and quickly growing fields of research is that of medical nanotechnology. As that future grows closer and closer, the question remains, what does nanotechnology mean for humanity? What is it going to mean when a deadly disease is no longer a life sentence? When human life is extended? When we in our lives are fundamentally altered by the introduction of small particles into our bodies? This is the question I hope to shed some light on today. When I say the word small, there's a lot of room for debate about what exactly small entails. Allow me to paint a clearer picture for you. There are 1 billion nanometers in a meter. That's 304,800,000 nanometers in a foot. 25,400,000 nanometers in an inch. Can you imagine something that's 1/25 millionth the size of your thumb? I'd say that's pretty small. Now, nanotechnology is the study and manipulation of materials at this nanoscale. Researchers studying nanotechnology experiment at the crossroads of physics, biology, chemistry, and materials science in the pursuit of a certain particle or robot that could save a life by potentially eliminating a tumor or clearing blockage in an artery. You're probably asking yourself, what's the big deal about these small things? Well, on the nanoscale, certain materials act very differently than they do in the normal world. You might be wondering, why is a high school junior so interested in complex medical technology, dealing with particles too small for the eye to see? Well, my interest in nanotechnology actually started in 7th grade, after watching a TED Talk. Since then, I've been eagerly reading scientific journals and keeping up with recent advancements with the hope of one day working in a lab. I want to be a biomedical engineer. I want to work with nanoparticle-based drug delivery and the role of robotics technology in medical systems. Nanoscience is, in essence, a marriage of biology, chemistry, and physics, and the creativity and interdisciplinary collaboration fostered by this field not only emphasize the core principles of scientific research, but the basic ideas that unite people in pursuit of a bright, better future. In order for me to illustrate my next point, I would like everyone to take a minute to imagine a scenario. Imagine that you are sitting in your doctor's office and you're told that you have pancreatic cancer. Imagine the immediate fear, the gut-wrenching anxiety, and the emotional trauma of this diagnosis. You are one of the predicted 1,688,780 people who will be diagnosed with the cancer in 2017. The American Cancer Society reports that in the United States, approximately 49,000 people are diagnosed with pancreatic cancer each year. 40,600 of these people will die as a result. That's a 17% survival rate. Imagine the immense financial and emotional cost of months or even years of excruciating chemotherapy or radiation in the hopes of maybe eradicating the tumor. Now, imagine that instead of having to undergo so much painful treatment, you could simply take a pill or get a shot, and within days or even hours, the threat of your tumor would be gone. This is the future of nanotechnology. Right now, researchers are building robots that can function just like blood cells. Microvivore and respirocyte nanorobots eat bacteria and analyze the oxygen level in the bloodstream. These nanoscopic robots can solve health problems in the fraction of the time it would take traditional antibiotics or chemotherapy. Promising research breakthroughs have recently generated a lot of excitement about the progression of nanoscale technology. The 2016 Nobel Prize winners in chemistry worked in the field of nanotechnology and actually created a functional motor that's invisible to the naked eye. Researchers studying the work of these doctors are very excited about the potential for future applications of the motor. Many believe it could be used for the injection of microrobots into veins that will look for and destroy cancer cells. This amazing achievement and the promising work of other researchers all over the world have made it a popular belief that we're living in the second wave of nanotechnology, and essentially anything's possible. Leading nanotech physicists have a unique ability to convey the enormous potential of nano research, while at the same time maintaining an air of playful curiosity and reality-defying optimism that have come to define this field. When the theoretical possibilities of nanotechnology are presented as attainable goals, as opposed to impractically absurd musings, people are inspired to experiment with open minds and the unquenchable sense of curiosity that lies at the core of scientific discovery. As nanotechnology research continues, there are several important questions that must be considered. What are the ethical applications of nanoscale robots being released into human bodies? If enhanced methods of mass production are discovered and implemented for nanoparticles, will this correlate to a change in the manufacturing industry? As nanotechnology becomes more advanced, how will the government regulate new products and ensure the safety of new treatments? With these questions in mind, researchers can move towards more viable experimentation while addressing public issues that may arise. As I mentioned before, it's popular belief that we're living in the second wave of nanotechnology. We are building on the surging energy of new discoveries and drawing from the passion and devotion of scientists who built the foundation of this field of study. Perseverance and commitment are crucial to helping new treatment methods move through clinical trials and make them accessible to the public. Increasing public awareness of nanotechnology through school programs and lab opportunities for students is critical to the future of this field. Offering summer programs for high school students or adding simple nanotech lab demonstrations to middle school science labs will raise public awareness about this rapidly expanding field and give young people the opportunity to explore their passions and experience the wonders of this field firsthand. The Epcot Center at Walt Disney World introduced a nanotechnology exhibit as part of an effort headed by Cornell University. This example gives me hope for a future in which major businesses contribute to a large-scale effort to introduce children to nanotechnology in an inviting and fun environment. So, what does nanotechnology mean for humanity? Well, what does it mean to be human? To be human is to have an open mind, to have an unquenchable sense of curiosity and a desire to improve upon what already is. To be human is to have empathy and to want to put an end to the suffering of others. To be human is to have an idea and to be the driving force that lets it move the world. Exploration of the possibilities of nanotechnology will strengthen our sense of humanity by emphasizing values of global collaboration and altruism, and I hope to one day be a part of this movement that will carry us into the future.